Most of the students watching this video may not actually get it at first, but I'm here to actually break it down for you. So let's go ahead and do that. The question on the screen starts off by saying calculate the volume of carbon dioxide gas produced at standard temperature and pressure when 11 grams of calcium carbonate is completely decomposed. So we have the equation over here. And then we have the relative atomic masses of the individual elements, and we have the last bit of information here, molar gas volume at standard temperature and pressure. So the first thing to do would be to get our balanced chemical equation. Now let's check out this equation if it's balanced. We have the first element, which is calcium. On the left side, you can see one atom of calcium, and on the right, one atom of calcium as well. Calcium is balanced. For carbon, you can see on the left-hand side over here, just one atom of carbon. And on the right-hand side, you can see as well, one atom of carbon. So carbon is also balanced. And finally, oxygen. You can see oxygen over here with three atoms. And on the right-hand side, we have one atom and two atoms over here, totaling three as well. So oxygen is also balanced. Now that the equation is fully balanced, let's check out the question one more time. It says, calculate the volume of carbon dioxide gas produced, CO2, at standard temperature and pressure when 11 grams of calcium carbonate, CaCO3, is completely decomposed. So from the equation, we're dealing with calcium carbonate and carbon dioxide. The next thing to do would be to get our mole ratios from the equation. Now, from the equation, you can see that calcium carbonate CaCO3 reacted to produce carbon dioxide. Each of them was 1 mole. So from the equation, 1 mole of calcium carbonate CaCO3 produced 1 mole of CO2. So therefore, we have 11 grams now of calcium carbonate reacting. Let's go ahead and convert that into number of moles. A number of moles is equal to mass divided by the molar mass. The mass of calcium carbonate in this case is 11 grams, as given from the question. The molar mass of calcium carbonate, we do not know it, but we can calculate it. It is given by CaCO3. Now, Ca is 40 plus C is 12 and oxygen is 16. 16 multiplied by 3 since we have 3 atoms of oxygen. So that gives us 40 plus 12 plus 48. So altogether we have 100. That's the molar mass of calcium carbonate. So the number of moles becomes 11 divided by 100. This is equal to 0.11 moles. So let's go ahead and plug that into our equation. Now we know that from the equation, 1 mole of calcium carbonate decomposed to form 1 mole of CO2. And we've calculated 11 grams over here to be equal to 0.11 moles. So therefore, 0.11 moles will produce an unknown amount or an unknown number of moles of CO2. If we cross multiply, this becomes the unknown number of moles for CO2 will be equal to 0.11 times 1. So therefore, we have 0.11 moles of CO2 produced. But remember, the question says calculate the volume of carbon dioxide gas produced. We have calculated the number of moles of carbon dioxide gas produced. So we want to convert that number of moles into volume. How do we do that? We simply use this relativity over here that says molar gas volume at STP is 22.4 dm cube. What does that mean? It means 1 mole of a gas occupies 22.4 dm cube or liters. Whichever unit you choose to use is perfectly fine. So if 1 mole occupies 22.4 dm cube or 22.4 liters, the number of liters that are 0.11 moles will occupy is unknown. So let's cross multiply. So when we cross multiply, we have this question mark times 1. This is equal to 22.4 times 0.11. 22.4 times 0.11. That gives us 2.464 liters or 2.464 dm cube. That is our final answer. I hope you got value for this. If you did, please do it to like, share, and follow for more as we eagerly anticipate the next video that be coming up.